Hey guys, welcome back to geometry. This is going to be our unit 7.3. These technically are not notes, but I do want to include them because you do need to know how to solve these problems when we have a parallelogram on a coordinate plane. Okay. If you don't remember, coordinate plane just means that we have some points that are at specific locations on a grid. And we need to be able to figure out if we have a parallelogram or just a quadrilateral. Remember, a quadrilateral is just a shape that has four sides, but a parallelogram has specific properties that make it a parallelogram. For example, we can prove that this is a parallelogram if the opposite sides are congruent. That is one of the properties of a parallelogram. So the way that we're going to prove that the opposite sides are congruent on a coordinate plane is if we can prove that from point A to point B and point C to point D are the same length. And in order to do that on a coordinate plane, we would have to use our distance formula. So let me go ahead and give you the notes for this. So if the segment AB is congruent to the segment CD, and if the segment DA is congruent to the segment BC, then ABCD is a parallelogram, and we would use the distance formula to figure that out. Remember the distance formula where you have distance equals the square root of y1 minus, I'm sorry, x1 minus x2 squared plus y2 minus y1 squared. Okay, if you don't have that formula memorized, I would go ahead and do that. The second method we could prove that we have a parallelogram on the coordinate plane is when both pairs of opposite sides are parallel. So how do we prove that something is parallel? Well, they have to have the same slope. So in this case, you would usually use your little parallel marks. And if AB is parallel to CD, and if BC is parallel to AD, then ABCD is a parallelogram. And in that case, we would use the slope formula. And if you don't remember the slope formula, it's our change in y over our change in x. So that would be y minus y, y1 minus y2 over x1 minus x2. Now, we can also prove that one pair of the opposite sides are congruent and parallel, meaning you don't have to find where this one is AB is parallel to CD, and then you do BC is parallel to AD, we have to prove that all four sides are parallel, right? But if we are able to prove that one pair of the sides are parallel and congruent, that also works, meaning AB is congruent with CD and AB is parallel to CD. You wouldn't have to prove that the other two sides are parallel congruent. You only have to prove that these two sides are. So if AB is congruent to DC and AB is parallel to DC, then we have a parallelogram on our hands, and we would have to use both the distance formula and slope.